of our lessons so the people that aren't here can figure it out too. All right, so basically you got this handout. It's about graphing absolute value functions. So that means you have to know how to use the calculator to graph, okay, and where to find the absolute value function, which even if you're pretty decent at the calculator, you might not know where that is. So just a couple of things first. All the keys on the calculator that you see up here are like your normal calculator keys, okay? Some of these you're used to seeing on scientific calculators. You want to get the blue stuff, hit second, and then hit the button. You want the green stuff, hit the green button, and then hit that. And then we have like graphing functions too. Nick, you can grab a calculator, and there's a handout on your desk. So basically, let's talk about the graphing first, okay? So all your graphing keys are up here. This is what makes this calculator a little bit different. So go to y equals. There might be stuff written in there, and there might not, depending on if it's your calculator, how it was last used, all this kind of stuff. First of all, we don't need anything that's already entered in there. So if any of your y equals have stuff written next to them, just scroll up and down and clear out the stuff that's there. So my cursor's right here. I don't want this equation in there. I'm going to clear it out. Okay? Some of you might have, see at the top, plot 1, plot 2, plot 3, those words up at the top. We're going to learn how to use those later on in the course. It's kind of like when you want to make scatter plots or use data, stuff like that. If those are bold, then they are on. For example, if it looked like this, all of mine are off. But if it had been like this, one of them is on. The issue with that is if that's not what I want to graph right now, my calculator is going to try and graph that stuff and the stuff I'm doing at the same time. It's not going to be able to put it all on the same graph, and it's going to have like some sort of error thing. So if any of those are bold, like you see right now on mine, just scroll up to it, press enter on top of it, scroll back down. So you should basically have nothing on your calculator that's bold, so we can type in whatever we want. Okay? When you type in equations, let's just say we want to just graph a basic line, okay, like 3x plus 1, okay? So you would just type in 3x plus 1. Now, they want to make it easy for you to get your x button, so it's right here. I know you see a green letter X on here somewhere. That's more to use the alphabet to, like, store stuff in. We are going to use this button next to the green alpha button every time we want to type a variable. So let's go ahead and type 3x plus 1. And then if you want to see that on the graph, you hit the graph button. So go ahead and press graph. Some people might see it and some people might not. How many people don't see a line? Okay, a couple of us. All right, so here's the deal. I typed 3 and then this for x and then plus 1. Okay, so if you got window range, go back to the y, quit that or whatever, go back to the y equals. And I'll talk about your guys' windows in a minute. So there's two things we can do. The calculator can zoom to some preset windows for us, or we can set the window ourselves manually. Basically, when you set the window, it's like when you draw a graph on your paper. So if I asked you to graph the line on your own paper, you guys would have drawn an x and y axis, and you would have put little tick marks on the axis, and you would have numbered them by 1s or 2s or 5s or whatever you needed to number them by, right? And you would have gone out a certain amount and up a certain amount and down a certain amount. We can control all of that in the calculator also, okay? So there's some presets, like I said, and then we can do it ourselves. So I'll show you the preset windows first, okay? The preset windows are all under the zoom option. So go to zoom. And you see a few options. If you want to get back to a really basic window that looks like your normal XY coordinate plane, they basically have one that goes 10 in every direction. So positive 10 on the x-axis, negative 10. Positive 10 on the y-axis, negative 10. That one is number 6, the zoom standard. Okay, so I can either scroll down and press enter on number 6, or I can just press the number 6. So you'll see that my window changed, and then I see the picture of my line. So if we all go to a zoom standard window, we should all see this picture now if we graphed the same line, and then we have the same window. Okay. Did that work, Michaela? Okay. If you don't like the window. Let's say you were trying to look at a certain part of the line. Like you were like, I don't need to see all this stuff out here. There's nothing even in that part of the graph. So I just want to like cut it off there, and I just want to look at that. You can control that, and you can type the numbers in yourself. And the way you do that is with window. Okay? So the window button right here is how you can control your window. So if I don't want the x minimum to be -10, I can retype it as -5. A small warning when you use this calculator. A negative is a negative button, and subtraction is a separate button. Okay? So see over here, division, multiplication, subtraction, addition. Those are operations. The negative button, if you just want a number or something to be negative, is down here by the decimal. The reason I point that out is if you type the minus button, but you mean negative, it's going to say error because the calculator thinks you wanted to subtract something and there's nothing there to subtract it from. Okay? So let's say I change the -10 to -5. And, oops, let's say I only want to go to +5 on the x-axis also. But I like my y values, so I won't change them. I just change whatever I want to change in there, and then I just press graph. It saves all my changes consistently. And so when I press graph, now I'll go back. Notice it looks pretty similar, but I just don't have as much space on the x-axis. You can see that it's only going out 5 notches instead of 10 because of the way I changed the window. Okay? So you can basically type in the equations you want. You can zoom back to the standard one whenever things are messed up. Try that. And then you can change it how you want after that. Okay? Any questions on that? Just graphing something basic and then seeing it in the window. All right, then where some other things are on this calculator, because we're going to be graphing absolute value, so we have to find a way to tell the calculator that it's absolute value, and you don't just type bars. Like there's not just absolute value bars on the face of the calculator. So a lot of the stuff is hidden in the math menu of the calculator. So you'll see there's a math button right below the green alpha button. Okay. So go ahead and go in there. So just a heads up in case you need to use this for future. They have cube roots in there, cubes. And then they also have, see number 5, how it has like an x and then a radical? Whatever number you type in front of that, you can take whatever root you want. So if I wanted to take the 5th root, I would type a 5, and then I'd go get this little x radical thing, and then I would type beyond that. Okay. Scroll to the right one. So all these things up here are new menus that you can go into. So if we scroll to the right one and we're on this thing called num, these are a bunch of different functions, just like a computer would have, about stuff you can do to numbers. So notice there's like a rounding one, a minimum, a maximum. We're going to use the first one, ABS, which stands for absolute value. Okay? So don't press enter or anything right now. Let me show you how we would type in the first one. So notice number 1 on your handout. Okay, how they got that graph is they typed in that equation. So we're going to go type in that equation now so you guys can see how to do it for the remaining problems on the page. Okay? So I'm going to go back to my y equals. I'm going to clear out the line equation that I put in there before because that's not what I'm graphing. And I'm going to type in equation number 1 from the handout you guys have. So the equation that says y equals the absolute value of x. Okay? So all I need after the y equals is the absolute value function with an x inside of it. Okay? So where do we get the absolute value function from? The math button. So math, scroll over to num, and you make the first choice, absolute value. Now, depending on how old your calculator is, it will show up differently, but it means the same thing. This calculator has software where when you pick the absolute value function, it literally gives you absolute value bars. So anything you type inside the bars is inside the absolute value. Okay. If the calculator is a little bit older, it might just say ABS with an open parentheses. It means absolute value bars, and whatever you want inside the absolute value bars, you type it, and then you close the parentheses. Okay? So all we want in our absolute value bars, if we're graphing number 1, is we just want an x. And remember that this is the place we quickly type variables when we're graphing stuff. So I'm going to type x inside of my absolute value bars. If I have one that looks like this, I'm going to type x, and then I'm going to close the parentheses. Your parentheses are right here above the 8 and the 9. And then I'm going to go ahead, just so that you guys know when you're typing stuff outside the absolute value bars, you would just arrow out. Okay? And I'm going to go back to that standard window where we see everything by tens. Okay? So I'm going to go zoom, and I'm going to choose choice 6. So there's the graph of an absolute value function. Does it match the graph that's on your paper? Okay, looks like it matches. And then we'll talk about how they picked out the other information. So any questions about how to enter the equation on the calculator? So you'll be able to do that. Anything you want to type inside the absolute value, just make sure you type it inside. If it's before, type it before you go get the absolute value. And if it's after, just make sure you close your parentheses or arrow out of your absolute value and finish typing after. Okay? All right, so that will be how you get the graph part of it. Okay? Notice in the right column next to the graph where it says coordinates of the vertex, 0, 0. This is the vertex of the graph, the place where it turns around. So they're just looking at the graph and saying, okay, it's 0, 0. And whether it goes up or down, they're just looking at the graph and saying it's opening upward. Okay? So the graph, the vertex, and whether it opens up or down, you will be able to see once you graph the equation. The A, H, and K there are a little bit different, so I want to talk about how they got that. So look at the top of your handout. Up where the writing is, there's kind of a general form of an absolute value equation. And this is kind of the purpose of why we're doing this activity. We're going to be able to graph everything by hand. But this activity is going to teach us, like, when numbers are in certain places, what do they do to the function? So the calculator helps us in the fact that we can graph a bunch really quick, and then we can try and, like, determine what different numbers do when they're located in different places. So at the top, you see this equation. So in each problem, like in problem number 1, the equation just looked like this. And do me a favor, and underneath this equation, will you guys write the word parent? Does anybody know what I mean when I write that down? You guys hear? Yeah, the parent function. So we're going to learn different families of functions. So absolute value is the first family we're going to look at. The parent function is like the most stripped down basic function that includes whatever it is you're looking at, in this case, absolute value bars. So there's nothing multiplying the x, nothing being added, nothing being subtracted. It's just like absolute value with x. That makes a parent function. Okay? To determine a, h, and k, you want to compare this general formula to your function. Okay? So a is going to be a number that multiplies in front of the absolute value bars. K is going to be whatever number would be added on after the absolute value bars. And h is a little bit tricky because notice in the formula what comes before h? A minus sign. And so that's going to deceive you a little bit with your eyes. You're going to see something, but change it, and I'll give you an idea about that in a minute. So in the parent function, they said the a value was 1. Because if you don't see a number multiplying something else, what number could be there multiplying it and it wouldn't make a difference? 1. Okay? It says the h value and the k value are 0. Because h and k are both being added and subtracted, but there's nothing in those spots. So what number could you add or subtract with something, but if it's not written there, it would be the same as if it was? 0. Okay, so when you're adding or subtracting something and it's not there, it's like you're adding or subtracting 0. But when you're multiplying something that's not visually there, it would be like multiplying times 1. Okay, is that all right with everybody, why those were what they were? Okay, so let me just throw out an example and see if you guys can figure out. Okay, so if this was the equation, what would the a value be? Okay, -4. What would the k value be? So k value is just plus whatever. So what are you adding on to the end? 5 positive, right? And what about the h value? 3 or -3? 3, good. Okay. So what if I changed this to a plus? -3. Okay? So if you guys are struggling with that, remember that inside the absolute value it's x minus h. So the reason when it said x minus 3, I said h was a positive 3, because a positive 3 was the number that somebody would put after the minus in the h spot to make it look like x minus 3. If they change it to x plus 3, the h would have had to be negative, because x minus a negative number is what would then make it appear like it was a positive number. So the H value is a little bit tricky. Okay? Does everybody follow that? All right, so your goal, and you can work with the people that you're seated with in your group, is going to be to get a graph off of the calculator for all the equations listed on this page, fill the A, H, and K values in, and then answer the questions of the vertex and whether it opens up or down. Your goal is to make decisions. What does A do to the graph? What does H do to the graph? And what does K do to the graph? Okay, and for some of you, this is kind of repeat of some stuff that you did last year. And for the others of you, it's not. It kind of seems new. So, work with people so you guys can share the knowledge. Right, you can just fill that in, correct. Okay, so as it's coming up, the first question you could agree or disagree with if you call it a rebound function or why he would call it that. So it's kind of your opinion. So the second question, how would you guys decide whether it goes up or down? A value. Okay, if it's positive or negative. So positive A means you expect the V to face upward. A negative A means downward, so you should have that written down here. So if A is positive, it's up. If A is negative, it goes downward. Okay? All right. Now, part C says summarize how the A value affects the graph. I would first make a little arrow to what you just wrote in part B. If A is positive, it goes up, and if A is negative, it goes down. That's part of it. What else did A control about your graph? Okay, good. So it controlled how wide or how narrow the V looked on the graph. Okay? You guys graphed 3 times the absolute value of x. Was that graph more wide or narrow compared to the parent function? Narrow? Okay. So does anybody have an idea of what exactly they think A controls for the absolute value graph? Malin? Yeah, it actually controls the slope of the sides of the V. Now, this is not going to work for every graph, every type of graph we learn. This, though, makes the absolute value graph really easy to graph because you have the slopes of the lines. You just need to kind of have a starting point for them. Okay? All right, how did changing the value of H affect the function? Hannah? Okay, so does H affects part of the vertex, but the x coordinate or the y coordinate? So H was the ones you did at the x coordinate, it shifts it like left and right. Okay? So H value is going to be the x coordinate of the vertex. That's going to be the important part for us to quickly graph the absolute value. And in the future, you're going to see other functions that also have this H value. So it's important to know that basically the H value is shifting your graph left or right. Because you kind of saw the same picture you saw before. It's just that all of a sudden it was over here or over there. And so the x coordinate of its vertex was a little bit different. All right, what about the K value? How did that affect the graph of the function? Good, the y coordinate of the vertex. So the K value represented the y coordinate of the vertex. Good. And then the kind of general idea that's going to help us later on besides just with absolute value is the idea that that number outside of the function shifts our graph up or down. Okay? So that should have been the basic trends that you guys saw. So then for the examples that are down at the bottom, so the first example is a graph like this. You have a better picture on your screen if it's hard to see up here where the x and the y axis are, but these are the axes. So the first thing I have to do, Kevin, will you come sit back in your seat? And Mia, you too, while we do this. When we work in groups, I don't care, but then once we're working together. All right, so if this is my graph, how am I going to write my equation? So I know some people had ideas because they started it and were asking me about it, and I said, oh, just wait, we're going to go through it. Yeah? Good. So the vertex can find for us our H and our K value. So here the vertex is at the point 2, 1. So 2 is our H and 1 is our K. So if we use that format to write our equation, 2 is our h and 1 is our k value. And then what's left to find is our a value. Hannah, can we finish and then you guys can have, thank you. Okay, so when we want to find this a value, do we expect the a value to be positive or negative first based on what the graph looks like? Positive, okay? The reason I point that out is because the absolute value function is actually something we call a piecewise function. It could be cut into two separate pieces. One piece is a line that goes this way, and then all of a sudden it's like that graph stops right here, and then we plotted another line that goes this other direction. Okay? One of these lines has a negative slope, and the other line has a positive slope. So when you go to calculate the slope, you'll always get one positive and one negative depending on which side you use. The number will be the same. So when you decide whether A is positive or negative, don't decide it whether you got a positive or negative slope of the line. If the V faces up, you should use a positive A value. And if it faces down, then you should use a negative A value. So our slope here, I would have to find 2 points that I could clearly see that the line crosses, and I would be thinking about the rise and run between those points. So my rise is 1 and my run is 4. So I would write the number, and then like I said, if I had done it this way, it would have been like a 1 and a negative 4. So the number part is still 1 over 4. I decide if it's positive or negative based on the way it's facing. Because it's upward, I'm going to leave it positive. Okay? So this would be the equation that best describes that graph. Any questions about how the absolute value equation works in context with the graph? Hopefully this is reminding you of stuff that you did previously. All right, so if we have an equation like number 2, we would first want to identify the a, the h, and the k value so we could then go and find those important parts of the graph. So what is the a value? So negative 1/2. What is the h value? Negative 3, good. And the k value? Negative 1. So remember, these two make your vertex. So our vertex will be at negative 3, negative 1. So we'll plot that point. And then we would use the slope of negative 1/2. So I'm going to use a rise of 1 and a run of 2. And then whether I make the v go upward or downward depends on if a was positive or negative. So should I make my v go upward or downward? Downward. So instead of going up 1 and then over 2, I'm going to go down 1 and then over 2 so that I know my v will go downward. And then I can finish that graph. Okay? So this is the basics of what we are doing here. I know there's some more examples with some coefficients in them. Okay? One quick thing about those, when you do see a graph that's not written in the format, you cannot say like the k is 3 and the h is 4 here. Some of that might be true, but some of it might not be true. In this case, because it's absolute value, you would actually want to factor out the 2 that was a coefficient of x, because this can't be h unless it's just x minus h inside the absolute value bars, which means this cannot be here, or else it doesn't fit our format anymore. Okay? So in this case, because of the properties of absolute value, you can actually separate the 2 and the x minus 2, the things that are multiplying each other. And you know the absolute value of 2 because it's just a number. The absolute value of 2 is just 2. So when you went to graph this, you would actually use this equation. So your a would be 2. Your h wouldn't be 2 like it might have looked like in the original, or 4, excuse me. It's actually going to be 2. And then your k would still be 3 because it was kind of unaffected by that stuff inside the absolute value. Okay? So your vertex would be at 2, 3. And then your slope would be up 2 over 1 and up 2 over 1 the other direction. Okay? All right, so tomorrow we're going to get a printout where you're going to write down specifically the parent function of the absolute value. I know we have a very short time. Okay? It's going to look like this. I have it for you guys so you don't have to print it out. You're going to write some important stuff about the parent function. and then you have some graphs to practice. Okay? And this is going to kind of lead into what we're going to do for the rest of this unit with a bunch of different graphs and their shapes. Okay?